Hello friends, today's question: a source of sound S is moving with a velocity of 50 meter per second towards a stationary observer. The observer measures the frequency of source at as 1000 Hz. What will be the apparent frequency of the source when it is moving away from the observer after crossing him? Take the velocity of the sound in the air as 350 meter per second. So this question is a combination of two Doppler effects. In the first case, it is given, let us suppose this is our observer and the source sound is moving towards the observer with a velocity of 50 meter per second. So we have Vs, that's the velocity of the source, and it is moving toward the observer. And this observer hears the frequency of the source as 1000 Hz. And in the second part, same observer, you can say same source of sound is moving away from the observer. And then we are going to find out what will be its apparent frequency when it is moving away from the observer. Okay. So we start with first part, when the source is moving towards the observer. Say frequency when source is moving towards the observer. And in this case, it is given that the observer is stationary. So we can write the frequency when the source is moving towards the observer, f prime is equal to f v plus v naught and v minus vs, where f prime is the apparent frequency. F prime is apparent frequency, which is in the first case is given as 1000 Hz, and f is the actual frequency, which we are going to find out. And we have v is the velocity of the sound in the air, v is the velocity of sound in air, which is given as 350 meter per second. V naught is the velocity of the observer, which in this case is 0. Velocity of observer, which is 0 as the observer is stationary, and Vs is the velocity of the source. Velocity of source, and that is given as 50 meter per second. So we substitute the value. F prime is our 1000, F and V is our 350, 0 divided by 350 minus 50, and we can write that our F will be equal to 1000 multiplied by 300 divided by 350. So this is the actual frequency of the source. So you can write that this is actual frequency of source. Now we are going to use this actual frequency of the source to find out the applied frequency when the source is moving away from the observer. So we say frequency when source is moving away from observer. So we can write the formula that frequency away, let us call it FA, will be equal to the frequency that is F, which is the actual frequency, V plus V naught divided by V plus Vs. Now it's a simple substituting all the relative values. So we can say for FA, F we just found out is 100, sorry, it is 1000 multiplied by 300 divided by 350, and V is our 350, V naught is our 0, and this becomes 350 plus 50, and we can write this as 1000 multiplied by 300, 350, and this comes as 350 divided by 400. This zeros, this cancels out, so we are left with that our FA is equal to 3000 divided by 4, and this comes as that our FA is our 750 hertz. So this is the apparent value of the frequency when the source is moving away from the observer. And the options that are given to us, we can say option number C is the correct option. Option C is correct. So this completes the question. Thank you.